Well, let's see the lambda as expression as event handler. This material basically, where the lambda expression, we talked about it in chapter 8 and also chapter 12. We talked about the interfaces. Action listener interface basically contains a single abstract method, which means that the definition of functional interface is basically fitting that requirement. So when we are calling the add action listener method of a menu, we can use a lambda expression to specify the action to be taken when associated with action event occurs. So in here, basically we can see the open item dot action listener action event, and then the next line. Basically, this code shows us the lambda expression used on event handler for using the open menu. So when a menu item is selected, the associate listener will receive an action event object with which it does nothing. And the body of the listener calls the open file method defined in enclosing image viewer class. Also, we can use a simplified syntax for lambda expression, and the code will be much simpler. And we will see it in here. We don't have it simpler form, but you can see it in page 473, a simpler version of it. So this is our image viewer project. So if we open our project, this is what we can see. Let's look at image processing class, which we have in image viewer 0-4. So if we go back to our project, and we can open this one, this package, image -04. And of course we will run it. Three new class: image panel, image file manager, and off image. Basically, off image is a class to represent an image that we want to display and manipulate. Image file manager is a helper class that provides a static method to be able to read the image file from the disk and return it to the OF image. And then we have the image panel, which is a custom swing component to show the image in the graphical user interface. So if I click new image and do this, you can see that now our file is it has open option and quit option. The open option is more complicated. It's actually opening a file. So I can basically maybe find a picture and open it. So you can see that it is processing the file. And I can always quit. So basically that off image class is the custom format for representing an image in the memory. You can think of image as a two-dimensional array of pixels. And we can use the class color from java.apt to represent the pixel color if we want. Off image is also implement a subclass like buffer image, and which give us the functionality that we want. And also the color, of course, using the color object. So basically, the method of image is get pixel and set pixel to basically be able to read and modify single pixel, and get height and get width to find about the image size. Image file manager class offers three methods also: one to read a name image file from the disk and return it to the off image, and one to write an off image file to the disk, and one to open file chooser dialog to let the user select an image to open, which we just did. This method can also read files in the JPEG and PNG format, so it can open that, and save method will write the files in JPEG. Image panel class implements a custom-made swing component to display our image. Custom-made swing component can easily be created by writing a subclass of an existing component. And it can be inserted into swing container and be shown on GUI. Image panel is a subclass of J component. And the other thing that we have to think about is that image panel has a set image method that takes an off image as a parameter to display any given image. So basically, these are the class responsibilities that we just talked about, and the off image, adding the image panel, loading an image. So for adding an image in here, we have basically we can see that we use the JFrame here. This is basically, and then we have the image panel. So we open the file, so that's open function, which is open a file chooser to select a new file image. And that's what we're doing here. And then basically we can create the swing frame and its component of it. And then load the image. So we are calling here one thing that's different from the other code that we looked at, frame.pack, is basically will recalculate the frame layout and redraw the frame so that the size of change is properly handled. So that's just one thing that we are going to use in here to call frame.pack at the end of open file. That's what we are doing here. So as the size of our image component has changed, this frame pack will actually recalculate the frame layout and redraw the frame so that the size change is properly handled. The next thing that we are going to look at will be the layout managers. Basically manage limited space for competing components. So the swing will use layout manager to arrange layout of components in the graphical user interface. And each container that holds the component, such as the content pane, has associated layout manager that takes care of arranging the component within that container. So Swing basically provides several different layout manager. One of them is called flow layout, border layout, grid layout, box layout, and each of these represented by Java class in the Swing library. And each layout is different ways the component under its control. So flow layout arrange all components sequentially from left to right. It will leave each component at its preferred size and center them horizontally, as you can see in here. If the horizontal space is not enough to fit all the components, then they wrap around it. So it doesn't fit, it will wrap around it. The layout can also be set to align component left to right. The next thing that we're going to look at is the border layout. Border layout, as you can see in here, it can place up to 5 components in an arranged pattern. 1 in the center and 1 in each at the top, bottom, right, and left. Each of these positions may be empty, so it may hold fewer than 5 components. The 5 positions are named center, north, south, east, and west, as you can see here. But some of them might be empty. The next one that we are going to look at is grid layout. As you can see in here, the grid layout is useful for laying out components in an evenly spaced grid. The number of rows and columns can be specified, and the grid layout manager will always keep all the components same size. So all of these are the same size. This is also useful for if you want to force buttons, for example, to have the same width. The width of the J button instances is determined by the text on the button. So basically based on this. So the size of them are the same, but you can see that when you write it, they all kind of fit in that. And then the next one is the box layout. Box layout, multiple components, either vertically or horizontally, as you can see in here. The components are not resized, so it could be bigger or smaller, and they will not wrap components when resized. By nesting multiple box layout inside each other, sophisticated two-dimensional aligned layout may be built. So no resizing in here happens. So all the layouts that we talked about are very simple. The key to building good-looking interfaces lies in one last detail. Layout can also be nested. So we are talking about nested containers. Many of the swing components are actually containers. So the containers appear to the outside as a single component, but they can actually hold multiple other components in each other. Each container has its own layout manager attached. The most used container is the J panel, and J panel can be inserted as a component into frame contents pane, and then more components can be laid out inside the J panel. So each container will also have its own layout manager. The next thing that we are going to look at is the dialog. Basically, model dialogues block all other interaction, and they force a response from the user. Non-model dialogue allow interaction in other frames, while the dialogues are actually visible. Dialog can be implemented the same way as JFrame. They often use the class JDialog to display the frame. For model dialog with a standard structure, there are some convenience methods in J option pane and make it very easy to show such a dialog. So basically, they are message dialing. This is a dialog that displays a message and has OK button to close the dialog. Confirming dialog. The dialog usually asks a question and has buttons like maybe yes and no, and cancel options. And then input dialog. The dialog includes a prompt and a text field for the user to be able to enter the text. So in here you are seeing a model dialog, which shows the about dialog in here. Basically, this was the last task to be done to complete version 1.0 of Image Viewer application. If we have done all the exercises, we should have a version of the project that can open image, apply filter, display status message, and also display a dialog. So basically, you can actually go and see up to there if you can see all of that, a dialog box. One other thing that we need to discuss before we finish this, we are only going to cover until 13.6 of this chapter, and we're not going to continue further. But one last thing that I want to mention is about image filters that we need to learn. Basically, image filters are the first step toward image manipulation, and we want not only to be able to open and display image, but also to be able to manipulate them and save them back to the disk. So we are going to add 3 simple filters. A filter is basically a function that's applied to the whole image. The 3 filters that we want to have is darker, lighter, and threshold. Darker makes the whole image darker, lighter makes it lighter. Threshold filters turn the image into a grayscale picture with only a few present shade of gray. And that's the other thing that we will do in our project. In this example, we can see the filters that basically applying to the image to make a change of some sort of a color of each pixel, and basically for the width and the height. So we are using this set pixel in here. So it's changing the pixel color value, as you can see in this comment here. So in here you can see the other filter, lighter, darker, and threshold. So as you can see, there were a lot of in here, a lot of duplication. So the best is to define a filter superclass or maybe the abstract, create function-specific subclasses, create a collection of subclass instances in Image Viewer, and define a generic apply filter method. So you can see it also in Image Viewer 2.0. So if we go here to our project, and if we open this package, we compile, so you can see this is a superclass generalization concept, and you have these 3 kind of a filter in here, the image filter, but you have the superclass here as abstract, as you can see. Okay, that is it for this chapter. We're not going to continue further. We talked until we discussed up to 3.6, and basically we are going to summarize the layout management, and that would be it for this chapter. Of course, learning to work with the layout manager will take some time and some trial and error experiment. So over time you will know the layout management very well, and so these are basically some of the basic of all the areas of GUI programming. So I hope you have enjoyed this lecture, and hopefully you will continue working with the GUI interfaces, and also learning more about Java. I hope you have a great summer. Take care. Bye-bye.